problem even worse. And this then becomes very small, and the death spiral happens again, right? General rule of thumb, avoid the death spiral, okay? So, we want to resuscitate, but back to your original point, the best resuscitation for a patient with PE is a little bit of fluid, maybe 250, 500 cc, and then vasopressors. Norepinephrine is probably the best choice. And if norepinephrine doesn't work, then you can add an inotropic W. Okay? So, generally speaking, we want to have those things very close at hand before we flood the patient with 2 liters of fluid and kill them by accident. Okay? So, the other things that we can think about are bridging patients to cardiac bypass. Okay? It's a fun story about cardiac bypass surgery, or ECMO. Right? Do you guys use that term, ECMO? Yeah, same in English, right? So, ECMO was actually invented by a guy named Dr. Gibbons when he was a fellow, so not much older than you. He was at Mass General, where I work, and he watched a patient with PE die. It was a young woman, and he sat there and there was nothing they could do at the time. And he said, if only we could bypass the heart and the lungs, then maybe we could save this woman, right? And that's the story of Dr. Gibbons. He sat there in his lab and he thought, if we could do this, we could save someone with a PE. So he went into his lab and he worked, and eventually he created the first heart-lung machine at Mass General. And then he went to the leadership at Mass General and said, I've created a heart-lung machine idea, and I would like to pursue this research because I think it can save lives. And Mass General said, no, that sounds dumb. Yeah, it feels very familiar to me. They said, no, we don't think that's a very good idea. So Dr. Gibbon left and went to Philadelphia, where he invented cardiac bypass and changed the world. Right? Not the proudest moment of Mass General, but hopefully we do better in the future. Right? But that's another option for these patients with severe PE. So, you've given a little bit of fluid, you've maybe put her on vasopressors. What do we do next? Okay, let's talk about that. Is she a candidate for thrombolysis? So the first easy question is, does she have contraindications?
She doesn't have hemorrhage.
Right? Her surgery was on her foot, so who cares? Right? It's not like it was in her brain or something. Right? Is she in shock? Yeah. Right? So, if you look back at the original data, the first use of thrombolysis was in this urokinase study from the 1970s. And I only put this up there not because you should be memorizing this data, but because that's when it first was invented. Right? This is the very first study from 1970 in JAMA looking at thrombolysis. The first time we said, this could be interesting. It's not a randomized controlled trial. Same thing here, right? But basically it showed that the severity of PE got better in these patients that received urokinase compared to a non-randomized sample of patients that got heparin. And it got people thinking, and it took 20 years of thinking, right, to get to the point where we did some additional studies and showed that the pulmonary angiographic score, so basically what we now call the Miller index, which is another way of thinking how many segments of the lung are blocked with clot, okay, that improved with thrombolysis. Now what's interesting is you're going to see this same measure. This same slide is going to come up over and over again, right? Ever since 1992. Okay? I was in university at the time. You'll see a decrease in pulmonary artery pressure. You'll see a decrease in the amount of clot. But what you don't yet see is a change in mortality. Right? A change in something that's actually clinically oriented, patient oriented. It's physiologically oriented. But it was a good start. It was 1992. Right? Nirvana was playing. Michael Jackson was still alive. And then we had thrombolysis.